In this video, we're going to talk about the statistics and probability topic of bivariate data. And let's take a look at what we may see on the ACT. When we're talking about bivariate data, we're looking at collecting data for two variables and then comparing that data to determine if there are any relationships there. So for example, someone may ask if having a college degree has any kind of relationship with the number of TV hours watched per week. So we're looking at two different variables and trying to look at any relationship. A lot of times we'll use a scatter plot to graphically show these relationships, and the two different data sets will be plotted. When we have a linear relationship, we're usually talking about finding a line of best fit or a trend line, and that's drawn so that it's as close as possible to all the points, but it may not be every point. Here's an example of a scatter plot here to the right, and it looks like they have plotted internet usage, which is hours per week, versus age. And so we have the different points that are plotted, which are indicated by the circles, and then a line of best fit has been drawn. You can see this line that has a negative slope. It comes close to all the points, but of course it's not exactly on the point. And we even have a couple of outliers we can see. As you can see, the point that occurs at about, 17 hours of internet usage and maybe around 36 years of age, that is one particular outlier. Well, there's a couple of others that you can spot on here, but you're drawing a line of best fit, and there's lots of different software packages that can be used. You can even do some of this on your calculator, but for the ACT, we're probably not going to have to actually develop an exact line of best fit. We might be looking for things that trends, like we can tell this has a negative slope. So things like that, but just being familiar with what a scatter plot is and these lines of best fit are important. So best fit, though, could be something other than a straight line. We may not have a linear relationship. And here are two such examples of scatter plots. We have ones that are more in a curve. The one here on the right is more like a parabola. But notice how the points that have been plotted, you try to draw a function that is the best fit. And so that's what we're looking at. So just to be familiar with it, could be something other than a straight line. And it's always a good idea, not only for bivariate data questions, but we have other type of questions, usually even around when we're doing transformations, to be familiar with those basic parent graphs. What a line looks like, y equals x, what the quadratic equation, what a quadratic equation may look like, what an x cubed may look like. If we're doing the absolute value of x, that one may not necessarily come into play with bivariate data, but these transformation questions are important. So review a little bit about parent graphs and make sure you know what those basic graphs look like. For the ACT, when we have a linear relationship, you may every once in a while see a question that comes up about a correlation coefficient, and this is indicated by R. It's something that can be calculated. I've never seen on the ACT where you have to calculate that, because that usually gets into a little bit upper level statistics classes, but they may give you that, and they may give you the R value, the correlation coefficient. And this is a measure that can tell us how well a linear model describes the relationship of the two variables that we're looking at. How close of a fit is that? R is measured on an absolute value scale from 0 to 1.0. And 0 is going to give us no relation, no correlation if you get a value of 0. As we get closer to 1, that's going to indicate the most correlation, and the sign is going to indicate what type of relationship. If you have a positive R with a positive relationship, that means as one variable increases, the other one's going to increase as well. In turn, a negative R value, which gives a negative relationship, means that as one variable increases, the other variable is going to decrease. And so let's take a look at this. We're given here a scatter plot showing a strong positive relationship. Remember, strong meaning it's close to 1, And positive meaning as one variable increases, the other variable increases. And notice that's going to indicate also a positive slope between these two variables, x and y, that we have on this plot. And they've given us this R value of 0.9684, which is very close to 1. So that gives us the strong relationship. And this is our correlation coefficient. And we say that these two variables, x and y, are highly correlated. We get that from our R value close to 1. Now let's take a look at an ACT type question. Pause the video here and you can try this on your own. The question says, which of the following correlation coefficients indicates the strongest relationship between variables? So we're looking at the strength of the relationship. And remember, that's based on the greater absolute value of an R value, the correlation coefficient. So when we take a look at the values and we take the absolute value of each one of them, we're going to get the largest value when we take an absolute value of that negative 0.9, which gives us the 0.9, and that's going to be answer choice A with the strongest relationship between the variables. Remind yourself it's not about positive or negative here. The indication positive, negative, if as one value increases what the other value does. But for strength, we're looking at that largest absolute value.